Okay, so I gave you this problem to start out with. Find L, R, and T. You guys talk me through it. How do I find L?
Square root of 50 millimeters squared plus 24 millimeters squared plus 50 millimeters squared.
Perfect.
57.45.
57.45 millimeters. Perfect. From all that information, how do you find R?
Inverse tangent of the width and the length.
So
inverse tangent of 24 divided by 50.
Okay, which gives us
25.64 degrees.
25.64 degrees for R. And T.
Inverse cosine of 15 divided by 57.45.
Okay, the depth divided by the length of the length of the bore, which is 74.86 degrees. Now, on a practical side, if this is drilling an angular hole through a piece of material, you can tell this isn't a real practical problem, because if you are taking a drill bit and hitting that surface at 76 degrees, or 74 degrees, whatever, that drill bit is most likely going to hit that surface and not penetrate. It's going to deflect off. It's too steep of an angle to be hitting at. So something like that, you're probably using a high-speed mill at least to get the hole started, and then running a drill through it or whatever. But the math is the same.
Okay,
Go ahead. What'd you have?
you mean milling a flat and then?
Well, you're actually taking it at an angle and using a mill to get a starter hole in it. Get a little notch like that milled in it so the drill hits a surface rather than hitting the angle.
Hey Todd.
Yes, sir.
For R, I don't agree with math. Isn't it supposed to be length over width and the length is 50?
Nope.
Is 24?
It's width over length.
Okay.
Because here's R, this is the opposite, this is the adjacent.
I haven't written down that.
Okay. Well, today what we're going to look at a little bit differently. What if, as we're looking at this, so we still have our block here. We're still going corner to corner. But what we're looking at is, if I'm looking at it from this side, here's my drill path. I'm given an angle here, let's say 32 degrees. If I'm looking at it from this end, here's my drill path, and I'm looking at an angle here of, let's say, 24 degrees. And I want to find the angle of rotation and tilt. And they're still going to be the same. If I draw this across, this is going to be R. Up here, this is going to be T. Notice I have not asked for the length of bore. Why would I not ask for that? We're given no lengths on here. If we were given a depth here or a thickness, we could go back and find that length of bore. And I will do an example with that in a little bit. For right now, however, all we are given is those two angles. And if that is all we are given, there are a couple of ways we can approach this. One is to do some really deep trig derivation and find some formulas that you can plug stuff into, which isn't terrible, but more stuff to memorize. And you guys all know how I am with making you memorize stuff. It's not my way of doing things. So for me, the easier way to approach this is to just pick a thickness, pick a depth. I usually choose either 10 or 100 millimeters or something really simple to work with. If I choose, let's say 10 millimeters here as a depth, now I can come back and I can find those dimensions. This would be my length, this would be my width, right? How do I find them? Well, I'm looking at this triangle here. I'll draw it off to the side. It's 24 degrees here. Where's the 10 go? Right there. Where's W go? Oh, right on bottom, right where it is, right? We have what two sides according to that angle? W is the opposite, 10 is the adjacent. And once again, we are using a tangent. So tangent to the angle, opposite over adjacent, and filling in what we know. Do we know the angle? Yes, 24 degrees. Do we know the opposite side? That's the W, that's what we're trying to find. Do we know the adjacent?
Yes.
Yes, that's the 10. So we're going to make it a proportion. We'll cross multiply. Tangent of 24 times 10 divided by 1. So tangent 24 times 10, and we know we don't have to divide by 1. 4.452. So this dimension here is 4.452, which would be, if I were going back up here, this dimension here. So back over to this side. Looking at this triangle. This would be 32. And of course my 10 would be right here. And here's L. My pen doesn't want to work over on the side of the screen. So anyway, once again we have opposite and adjacent. So we're dealing with a tangent. What can I fill in? The angle is 32. Okay, the opposite side is L. The adjacent is the 10, even though it doesn't really look like it there. Over 1, we cross multiply. Tangent of 32 times 10. Gives us 6.249. And we had guessed this to be 10 millimeters before. Now we have all those dimensions, so we can go ahead and find all of our angles. Angle R is going to involve these two. Angle R will be the inverse tangent of 4.452 divided by 6.249, otherwise known as 35.47 degrees. Do you guys concur? Angle T is a little trickier though. Angle T, we've said, is the inverse cosine of the depth, which would be 10, divided by L, which is this length. We don't know that length because we said it was irrelevant, right? But we still need to calculate the theoretical. Once we assume that this was 10, we still need to calculate that theoretical length just to find that angle. The length we're going to find here is meaningless to the actual thing. It's not the real length, but it's what we need to know to find the angle. Does that make sense? Mm-hmm. Yeah. Because we guessed this dimension, it's not really the true length. So that length is going to be the square root of 10 squared plus 6.249 squared plus 4.452 squared, which gives us a length of what? $12.604. Perfect. So over here, this is the inverse cosine of 10 divided by 12.604. So 37.50 degrees. Not so bad? Okay, well, let's take a look at one for you guys to try. And I am going to give you on this one 20 millimeter depth. That way everybody's using the same numbers. So we'll pause this and let you. Okay, so what's your first step?
The width.
So this one here, okay. How'd you find that? Okay, we'll draw her up here for you. So what do we have on this triangle?
We have the 33, but 33 being up top,
Okay,
20 on the top, and W being bottom.
okay. And then?
We use
Tangent of 33.
so you have W on top, 20 on the bottom.
Okay. So we cross multiply to get 12.99. Oh, 988. Yeah, we've been going 3 decimals on our measurements, haven't we? So 988. Okay. Now it's next. Okay. Okay, tangent. And we get.
Why was I getting negative 5?
Okay.
17.3. I did that exact same thing. I was getting like negative 5.
What do you tangent of 40 times 20?
Tangent of 41 times 20.
It was giving you a negative 5?
Yeah.
You have to close the parentheses on that.
That's the other thing that happens is sometimes if you get put in radian mode, well, 41 radians is quite a few degrees. So 17.386 is what we come up with. So we've got 12.988, 17.386. Now what? So R, of course, will be right here. How do we find R? Okay, which will give us what? 36.73 degrees. That works. Then what?
Before we can go any further, continue, we have to find out that length.
Got to find the length here. You're right. Which is going to be what?
29.793.
Okay, it's the 20 squared plus 17.386 squared plus 12.988 squared. Which is what?
29.793.
29.793 millimeters. So then we can find our beloved.
Longer than what I got 29.51.
Oh yeah, let's do this a shot.
Square root
Square root
of
20 squared
plus 17.386 squared.
Yep. Plus
12.988 squared. Oh, I got
29.512.
That's what I got.
Okay.
Unless I'm looking wrong.
No problem.
29.5014.
At 29.512. Still off?
I'm still off.
Pretty sure mine is in right there. Double check. Punch in again. We'll wait for you. 386.
Squared plus 12.988 squared. 29.51.
There we go. There you go. Third time's a charm.
Excellent.
So now for our beloved T, this here, what do we do? The inverse cosine of perfect 20 over 29.512, which gives us 47.34. Perfect. So, in this case, I gave you the depth, the 20 millimeters. Because we had the 20 millimeters given, this length is actually the length of bore. Now, here's a challenge for you.
You were doing it.
Don't they have things on these smart board projector programs where you can just, they're like automatic shapes that draw out? All you gotta do is like drag them to the side.
That's no fun.
It's fun when
Part of the reason they do have some of those, they don't have the exact shapes I want, but they do have some that would work. Part of the reason I do this is most of the classes I work with, there's a visual gap. Not to be mean or insulting, but way too many young people now sit in front of a video game or a television. They're not playing with Legos or Lincoln Logs. They're not building things and seeing it. So I intentionally draw these out just so you can see it being put together and start to see the visual connections.
I don't sound like Curtis, but I stuff
You do. But I mean, there's a reason why I draw them out, and I struggle with it. You can see I'm not a great artist by any means.
Oh yeah, and on
But-
the test,
You
and
haven't
on
gotten any better.
No, I don't get any better.
And on the test when they like aren't decided or something.
Yeah.
They are like it can be a little. I understand.
Yep. But I mean, it's seeing the pieces, watching me sketch it out for some people helps them start to visualize it a little better because they're forced to watch my thought process as I try to make it look three-dimensional. And I suck at art just as bad as anybody, but I can look at the pictures and visualize it. I just can't draw them. So anyway, I want you to try to find W and L for me. See what you can do there. What can you find first here? Anybody have any clues? Okay. We have no choice really but to start with this triangle here that I just put in the green. So if we bring that one out, we're looking at this. What do we actually know about that triangle? It's 30 high, and this angle is 32 degrees. Now I'm going to find both of the other sides. Now the hypotenuse of that, of course, is our length of bore, which we didn't have to find, but we're used to having. So let's find that first. That right there. How do we find that? Well, what side is this? Adjacent. And this is the hypotenuse. Adjacent hypotenuse make what trig function? Cosine. So what can we fill into that formula? Cosine of 32 degrees, yep, we'll put it over 1 equals 30 over script L, right? Our length. So to solve that, it is 1 times 30 divided by 32. So 30 divided by cosine of 32. 35.375. So we have that, 35.375 millimeters. Now what? Find the bottom down here. I could use a tangent if I wanted to, but I'm just going to do this. It is the square root of 35.375 squared plus or minus? Minus 30 squared. Good. So second square root of that answer squared minus 30 squared. 18.746. Using the tangent, it should be exactly the same. So that is the length across the bottom down there, corner to corner. Here's where it gets a little tricky. That's your hypotenuse, yes. So now, this is where that visual thing comes in. Now we're looking at this triangle. What was the bottom of this triangle, one of the legs, now becomes the hypotenuse of the other triangle. What was that again? 18.746. And this is 20 degrees. Now what? This is W, this is L. Which one do we want to find first? W. Okay, what trig function? Sine. Good. This is the opposite. This is the hypotenuse, which is our sine. Wow, I might should work on some handwriting today. So what do I plug in there? Sine of 20 degrees equals perfect. So we'll cross multiply. Come on. Sine of 20. I'll just do that times the sine of 20. Is 6.411 or 412. We just found W. How do we find L? Yeah, we use a cosine. Is adjacent of our hypotenuse. Or we could do the, square root of 18.746 squared minus, So the L over 18.746 I'm cheating here for a second just so I don't have to punch stuff back in. 19.949, is that what you come up with? No? Okay. I might actually have to punch it in. So 18.746 times the cosine of 20. 17.614? Okay. So in going backwards, it looks like a lot more difficult problem, but it's not really, is it? The biggest thing is seeing this part of this triangle becomes this part of that triangle and going down through them. With that, in your packet, page 401 to 404. Check in this packet, make sure it's in this one, or if I have to give you a new one. No, we've still worked on the same one for Monday.
Extra credit.
Ah, yes, I do have an extra credit problem I have to give to you.
John. Remember that yet?
Remember it a little too late.
Did anybody check? Is page 401 in your packet? Yeah. It is, okay. Here's your extra credit problem. It is worth a potential of 20 points, which is 2 full quiz grades. Some of you could use that. Find the area of, make sure this is recording, yep. This is tangent. And this is a 1:4 slope ratio. This height out here is 10 feet. This height here is 24 feet. This width here is 72 feet. Now the fact that that width is 72 and the height is 24 tells us what about this piece? It's not what?
Not half circle.
It's not a half circle. Good. It's a segment of a circle. The center of that circle is somewhere down here. Find the area of this whole thing. This is due by the end of the semester. So literally you could turn it in on the 12th or 13th or whatever. You are allowed to ask questions of David and Bridging on this one if you want to. You do have an exercise to do over there today as well, so make sure you're over there to do that. Otherwise, we'll see you tomorrow.
Of course, the exercise is gonna be long, and I didn't go over it until I wasn't here.
Actually, we didn't go over this one at all as a group.
We had a worksheet with one of mine.
Something similar, but not just like this one. This one's a little different.
This one's different, 'cause it's not a half circle.
No, not this.